Okay, in this session we're going to talk about complex numbers. Alright, and basically when we're talking complex numbers, we're just saying when you're adding or combining real numbers with multiples of what we consider to be imaginary units. Alright, so complex numbers are a combination of real numbers and imaginary units. Well, that begs to begs you to ask the question of what is an imaginary unit. Okay, well, imaginary unit was just basically a clever way for mathematicians to deal with taking the square root of a negative number. Alright, we talked about on a couple of occasions how we can't take the square root of a negative number. Well, an imaginary unit is defined by I equals the square root of a negative 1. Alright, okay, so this again is a way for us to deal with taking the square root of a negative. So we use I, imaginary, to represent the square root of negative 1. Okay, so if that's the case, then if we were to square I, then that would equal a negative 1. So I equals the square root of negative 1, and if I squared I, if you square I, we talked about how square cancels square root, so I squared would equal negative 1. Alright, so just wanted to show you that. So again, two things we're looking at for imaginary unit is I equals square root negative 1, and I squared equals just negative 1. Alright, these are two things that you need to make sure you remember for this session. Okay, now when it comes to putting complex numbers into what we call standard form, alright, our standard form for complex numbers is A plus BI. Alright, A plus BI. Okay, where A would be considered the real number and B would be the coefficient or multiple of an imaginary unit. Okay, and the two come together to form what we call a complex number. Now again, I'm just giving you some perspective on complex numbers as it relates to imaginary units, but the real thing I want you to do is focus on understanding that I equals negative 1 and I equals square root of negative 1 and I squared equals negative 1, and then how to take that information and go forward and perform operations, adding, subtracting, multiplying, dividing, perform operations with complex numbers using this knowledge of I equals the square root of negative 1 and I squared equals negative 1. Alright, first of all, we can do some basics like, let's say, adding or subtracting. Okay, so let's say we had something like 4 plus 7i plus 1 minus 6i. Alright, if you can remember back to the work we did in polynomials, this is really nothing more than how we did polynomial addition and subtraction. Treat I like a variable like x or something like that when we did polynomial addition, and all you want to do is combine like terms from one set of parentheses with like terms of another set of parentheses. Okay, so in this first set of parentheses our constant is 4, in the second set of parentheses our constant is 1. So we combine our 4 and our 1 to get 5. Alright, those combined, 4 plus 1 is 5. That gives us our constant term. Alright, then we look at our I term, which is the 7i and a negative 6i. So we say 7i minus 6i would give us a positive 1i, or just I. So that one and that one combine to give you the I. Alright, so 7 minus 6 would be just 1, or a positive 1i. So this is your answer. right? This would be considered your A because we're putting it in standard form. So 5 would be your A, and your B in this case, since you don't see a number, your B would just be understanding that there's a 1 right here. Alright, that there's a 1 right there in front of the I, and of course there's your I. So A plus BI. There's your answer. So again, this answer is 5 plus I. Alright. An example of subtraction. Let's say we had 1 plus 2I minus 4 plus 2I. Alright. 1 minus 4 gives me a negative 3. 2I minus 2I gives me 0I. So I end up with just negative 3 because 2 minus 2 with my eyes, 2 minus 2, they end up canceling. Okay, so you just end up with negative 3 for an answer. Alright, say okay, well these are kind of simple. Let's try one more a little more complicated. Well, let's go with 3 plus 2I, alright, plus 4 minus I minus 7, put this in parentheses, plus I. Okay, so 3 plus 2I plus 4 minus I minus 7 plus I. Alright, doesn't work any different. You're going to say 3 plus 4, which is 7. Then you have minus, so 7 minus 7 gives you a 0 for your constant term, for your A. So your A in this case would be 0. So these end up canceling each other out. That's 3 and 4 is 7. 7 minus 7 is 0. Then you look at your I terms. You have 2I minus an I, or 2I plus a negative 1. 2 plus a negative 1 is just 1I. Alright, 1I minus another 1I. 1I minus 1I gives you another 0, or they cancel. And so you just stuck with an answer of 0. Alright, so there's really not much to it. Again, just treat it like you did when adding and subtracting polynomials. Just grouping together like terms from each set of parentheses. That's all we're doing. Okay, so that's considered addition and subtraction of complex numbers, what we just did. Addition and subtraction of complex numbers. Okay, now let's erase that. So now let's focus on multiplication. Alright, multiplication of complex numbers. So start with something basic like 4 times a negative 2 plus 3i. And this would be just like multiplication of polynomials. You do your distribution. So you end up with a negative 8 plus 12i. And there's your answer. Negative 8 would be your A, 12 would be your B, and there's your I. Okay. Let's say instead you had 2 minus I, 4 plus 3i. Alright, so a binomial, 1, 2, times another binomial, 1, 2. Alright, you can look at it like that. So this could be a FOIL situation. Binomial times a binomial. So first times first. First times first gives me an 8. On the outside, outside and outside, I get what is that, 6i, because I say 2 times 3i is 6i. Then on the inside, negative I times 4 is a negative 4i, and then last times last is, what is that, negative 3i squared. Okay, now just like when you did for with polynomials, your outside and inside terms tend to be like terms, and you were able to combine them. So if you combine your like terms, you get 6 minus 4, which is a 2i, and then you bring down your minus 3i squared. Alright, but now here's the kicker. Here's where this differs from what we did with multiplying polynomials. We talked about in the beginning I squared, and we said I squared is the same as saying negative 1. So really what we're looking at is 8 plus 2i negative 3 times, instead of I squared, it's like saying times a negative 1. So that 3 times that negative 1 turns this into a positive 3. And notice also we got rid of the I squared, so now you have a constant and a constant. Those are like terms, so they can be combined. 8 plus 3 is 11, and you bring down your 2i because it's not like the 11. Alright, there you go. This would be your final answer. Okay, 11 plus 2i. Let's look at another one. Alright, let's say we have 3 plus 2i times 3 minus 2i. Alright, now before I work this out, I want to introduce a term we call conjugates. Alright, and we'll talk about the usefulness of conjugates in a little bit. But basically, conjugate is like saying you have two binomials, alright, but the only difference is that are the exact same. Conjugate is saying you have two binomials that are the exact same, the only difference being the sign in the middle. The signs in the middle are opposite. That's what makes conjugates. Alright, so if you had 2x plus 3, the conjugate would be 2x minus 3. The sign in the middle is opposite. If we're talking about I, let's say if you have 4 minus 3i, its conjugate would be 4 plus 3i. So everything is the exact same except for the sign in the middle. That's how you form a conjugate. And again, we'll talk about the importance of using conjugates in a little bit. But alright, let's get back to this problem. Erase this little circle here, circle here. Okay, so again, a binomial here, 2 terms, binomial here, 2 terms. So we can FOIL. So first and first is going to give me a 9. Outside is going to give me a negative 6i. Inside is going to give me a positive 6i. Last and last gives me a negative 4i squared. Now, what we notice with conjugates is, if you look here, our outside and our inside terms, they're, because the binomials we started with were the exact same with opposite signs in the middle, our outside and inside terms end up being the exact same with opposite signs. So what they end up doing is canceling each other out. Okay, so now you're really just left with what you got when you said first times first and last times last. So you bring down your 9 and your minus 4i squared. Well, again, we talked about what I squared means right here. So it's really like saying 9 minus 4 times a negative 1, and this negative 1 times this negative 4 becomes 9 plus 4, and you end up with 13. So there's your answer there, just 13. Okay. We could look at one like this. Let's say you have 3 plus 2i squared, something like that. Well, we know that anytime you square something, it's the same as actually writing it out twice. Alright, So because it's squared, I wrote it twice, here and here. The exact same thing. This is not a conjugate. Remember, with conjugates, the sign in the middle are opposite. This is something squared, so it's going to be the exact same twice. The exact same twice. So we have that. So we do our FOIL. First and first gives me 9. Outside gives me a positive 6i. Inside gives me a positive 6i. And last gives me a positive 4i squared. Outside and inside are like terms. So you have 9 plus 12i plus 4 times a negative 1, because I squared is a negative 1. So 9 plus 12i minus 4, because 4 times a negative 1 is a negative 4. The negative 4 and the 9 are like terms, so 9 minus 4 is 5. And you bring down your 12i because it's not a like term. There's your answer in standard form. A plus bi. Alright, 5 is your A, 12 is your B. Alright, so there's your multiplication. Alright. Now, again, still talking about conjugates. Let me erase this right quick. Erase all of this right quick. Just bear with me. Okay. Now again, we're shifting our focus from multiplication now to talking about division. Alright? And this is where conjugates comes back into play. Again, we said conjugates, if you have a binomial, let's say, and you need to get the conjugate of it, you keep everything the same, you just change the sign in the middle. Okay? So, using these as examples of conjugates, alright, we can do some division problems. Now, the thing you need to understand is when you're doing division, you can't have a complex number in the denominator, alright? Or we want to get rid of a complex number being in the denominator. So, just like we don't like square roots in the denominator of a problem, we don't like i's in the denominator of a problem. So let's say if we had a problem like 2 plus 3i over 4 minus 2i. Alright, so once again, our issue, this is division, something over something. Looks like a fraction, right? Something over something, that means division. And we have an I in the denominator. And we're saying we don't want that. We want to try to get rid of that I in the denominator. Okay? Well, the way we do it is similar to what we would do for radicals. Alright, we want to multiply this by its conjugate. So to get rid of the I in the denominator, we're going to multiply our denominator by its conjugate, which in this case happens to be 4 plus 2i. Everything's the same except for the sign in the middle. That's what I mean by conjugate. Alright, now if we do it to the denominator, we also have to multiply the numerator by the same thing. Okay, so now what we end up with is we're foiling the top. So first times first gives me 8. Alright, outside gives me a plus 4i. Inside gives me a plus 12i. And last times last gives me a plus 6i squared. Again, first times first is where my 8 came from. Outside times outside is where my 4i came from. Inside times inside is where my 12i came from. And last times last is where my 6i squared came from. Now on the bottom, we already talked about before how when you multiply something by its conjugate, the outside and inside part cancel, so really all I have to do is worry about the first times the first, which is 16, and the last times the last, which is minus 4i squared, right? 4i squared. We've talked about what it means to have I squared, so we deal with that. And here, up here, those are like terms. So now we have 8. 4 plus 12 is 16i plus 6 times a negative 1, because our I squared is a negative 1, over 16 minus 4 times a negative 1. Alright, because of this I squared. That's where this negative 1 comes from. So you have this being 8 plus 16i minus 6 over 16 plus 4. Alright, because a negative 1 times a negative 4 is a positive 4. Like terms here and here. 8 minus 6 is 2 plus 16i over 16 plus 4, which is 20. So here you go. But remember, we like to write our answer in standard form. So to do so, what we do is we take the 2, write it over the 20 in the bottom. Take the 2, write it over the 20 in the bottom, plus, because you see the plus sign right there. Then we take the 16 and write it over the 20 in the bottom. The 16 over the 20 in the bottom, and we stick the I on the end of that because it's right there. Alright, now 2 over 20 reduces down to 1 over 10 plus 16 over 20. Alright, what, 4 goes into that 16 4 times, 4 goes into 20 5 times, so it reduces down to 4/5. Alright, so your answer in standard form ends up being 1 over 10 plus 4/5 I. So this whole thing is my A, that fraction there is my B, and there's my I. So A is 1 over 10, B is 4 over 5. There's my I. There you see an answer written in standard form. Okay, let's look at another one. Let's say we had a problem like here, write one like this: 6 minus 7i over 1 minus 2i. Alright, and we're asked to find the quotient. Okay, division, what they're going to say is find the quotient. Quotient. And quotient is just the answer for division. So same thing here. Find the quotient. Alright, so we're going to multiply by the reciprocal on the bottom to get rid of this I down here. So that's going to be 1 plus 2i. And if we multiply it on the bottom by that, multiply the top by that, the numerator. So now we end up with, up top, first and first gives me 6. Outside is going to give me 12i. Inside is going to give me a negative 7i. Alright, last and last is a minus 14i squared over, down bottom, I'm just going to square my 1 because it's first. My outside and inside will cancel, and then minus 4i squared. Alright, minus 4i squared is the problem that we have. Okay, so simplifying, I have my I squares that become negative 1s. Okay, like terms here and here. So what I have now is 6. 12 minus 7 is a positive 5i, and a negative 1 times a negative 14 is a positive 14 over, this is a negative 1. Negative 1 times a negative 4 is a positive 4, so 1 plus 4. Alright, like terms here and here, so that gives me 6 plus 14 is a 20 plus a 5i over 5, because 1 plus 4 is our 5. Again, we have to take this, put it in the proper form. 20 over the 5 plus 5 over the 5i. 20 over 5 is 4. 5 over 5 cancels and just leaves I. So your answer is 4 plus I. Alright, so that's how you find the quotient, or in other words, you perform division using conjugates. Okay. Alright. Now a couple other points we want to make mention of. Alright, let me erase, be quick about this. Erase everything, and once again we want to make sure we remember I equals the square root of -1. I squared equals just -1. Okay. Now, let's say we're given a radical like square root of a -48. Okay. And we've talked about how we can't take the square root of a negative. Okay. Alright, so we look at this -48 and say, okay, well, we can't take the square root of a -48. But what we can do is we can say the square root of -48 is really like saying the square root of 48 times the square root of -1. Because 48 times -1 is -48. Alright, so we can say the square root of a -48 is like saying the square root of a +48 times the square root of a -1. Now, we can break down our 48 by saying, what is that? 16 times 3, right? 6 and 3. Yeah. So this would be like saying the square root of 16 times the square root of 3. Alright, so 16 times 3 is where 48 comes from. So 48 would be like saying the square root of 48 is the square root of 16 times the square root of 3. And we know that this square root of a -1 is just I. So now we know square root of 16 is 4. Square root of 3 doesn't give us an integer answer, so we leave it under the radical. And then we have our I that we put on the end. Okay. Let's look at another one. This is just kind of simplifying a radical with a negative radical. Alright, let's look at another one. Make sure we got this. Let's see. What would be another good one? Let's say square root of a -75. Okay, square root of -75. Well, I know square root of -75 is like saying the square root of 75, alright, times the square root of a -1. Well, 75 is like saying the square root of 25 times the square root of 3, because 25 times 3 is 75. And I know that square root of -1 is just I. So now I can break this 25, excuse me, this 25 becomes 5, because square root of 25 is 5. Can't break that down to give me an integer answer, so I leave it under the radical. And then I just stick my I on the end. Notice when I put my I on my answer, I write it on the end. It is not under the radical. It is not under the square root sign. It's outside of the square root sign. It's important that you understand that. That radical stays outside the square root sign. Okay? And then lastly, what we want to do is just discuss how to solve equations, alright, that may give you a complex solution. Okay? And we're going to talk about this in terms of, alright, using the quadratic formula, where x equals -b plus or minus square root b squared minus 4 times a times c all over 2 times a. Alright, quadratic formula. Quadratic formula. Okay. Alright, so let's say we're given a quadratic equation like x squared plus 4 equals 0. Okay, and we're asked to solve. So solve for x, define x. Well, typically what we try to do is say x squared equals a negative 4, right? Because you subtract 4, 4's will cancel. Now you got the negative 4 on the other side. Take the square root, okay? Well, your square root and your square cancel because they're opposite of they're opposed to one another, inverses of one another. So now you have x equals the square root of a negative 4. Well, we know that negative 4 is like saying the square root of 4 times the square root of a negative 1. And we know the square root of 4 is 2. But it could be a positive or a negative 2, right? Because a negative 2 squared is 4 and a positive 2 squared is 4. So it can be a negative or a positive 2. And we said that the square root of a negative 1 is just I. So your answer would be plus or minus 2i. Alright? Now that was a way to solve it how you're typically used to solving general equations, alright, as opposed to plugging into the quadratic formula. But let's say we have one like this, where you have 3x squared minus 2x plus 5 equals 0. Alright? So it's in your traditional form. There's your a. The 3 is your a. The negative 2 is your b. 5 is your c. Alright, so it's in your traditional form. So now you can plug into the quadratic. So you have a negative 2 plus or minus square root of a negative 2 squared minus 4 times a, which is 3, times c, which is 5, all over 2 times a, which in this case is a negative 2. Okay, so this gives you 2 plus or minus square root, that's 4, minus 4 times 3 is 12, 12 times 5 is 60, alright, all over a negative 4. Okay, this breaks down to 2 plus or minus 4 minus 60 is the square root of a negative 56, all over negative 4. And now we treat this, okay, like we just did those last problems. We have the square root of a negative. Okay, so we know that that negative square root of negative 56 is like saying square root of a positive 56 times the square root of a negative 1. Okay, so we break our square root of a positive 56 by saying that's what, let's see, 4 4 goes into that, 1 left over, 16, 4, 14. Alright, so 4 and 14, is that right? Yeah. So 56 is like saying the square root of 4 times the square root of 14. Okay, 56 is like saying square root of 4 times the square root of 14. Alright, because 14 times 4 is 56. So we have our 2 plus or minus square root of 4 times square root of 14 times square root of a negative 1, right? Because we said our negative 56 is like saying a 56 times a negative 1, with this being the 56. This gives us the 56 times the negative 1, right? Again, we say 56 is 4 times 14, and this is all over a negative 4, and the 4 times the 14, so you have 2 plus or minus square root of 4 is 2. You can't break 14 down to get an integer answer, so you leave it under the radical for 14, right? And then we said the square root of negative 1 is just I, all over a negative 4. So now you have your 2 here over your negative 4 plus or minus your 2 radical 14 over your negative 4 with the I attached to the end. This right here gives you a negative 1/2 plus or minus. This 2 over 4 will give you 1/2 again, but you don't have to write the 1 since you have the radical 14 in the top. With that right there. Alright, let's see. Did I do that right? Uh-oh. I think I did something wrong. Uh-oh. My 2a. I wrote my b down here. Okay. Work with me. This is supposed to be 3 instead of a negative 2. I wrote that as a b as opposed to a. Let me change that right quick. So this changes, this changes, this changes, this changes, this changes, this. So now let me rewrite it. That's supposed to be a 3 because it's a, right? It's over 2a, and a is 3, so 2 times 3. Alright, which gives me a positive 6, positive 6, positive 6, positive 6. So positive 6. So positive 6. Now, of course, you don't have to write the plus sign. Alright, so 2 over 6 is a positive 1/3 plus or minus that 2 over 6, which becomes another 1/3 I. So 1 over 3 plus square root of 14 over 3, which I tacked on, oops, plus or minus, with that tacked on there at the end. Okay, there's your answer. Alright, let's try one more just to make sure we're comfortable with this. So let's do one over here. Erase. Okay, so let's say we have, oops, let's say we have x squared plus 6x plus 10 equals 0. So my a would be 1, my b would be 6, my c would be 10. So minus b plus or minus square root of b squared minus 4 times a times c all over 2 times a. Okay, so negative 6 plus minus square root 36, that's 4 and times 10, so that's going to be 36 minus 40 over 2. Alright, so now we have negative 6 plus or minus square root, that's going to give me a negative 4 over 2. And we said that negative 4 is like saying square root of a 4 square root of a negative 1. So it's negative 6 plus or minus square root of 4 is going to give me a 2, and the square root of negative 1 is going to give me an I over 2. And then we look at this like this to reduce. The negative 6 over 2 is going to give me a negative 3, right? The negative 6 over the 2 in the bottom is negative 3 plus or minus, plus or minus. Then the 2 over 2 is 1, which just leaves 1i, and there's your answer. Negative 3 plus or minus I. Alright, and that's solving equations with complex solutions using the quadratic formula. Alright, so hopefully this helps you understand various ways we can deal with taking the even root of negative numbers by using imaginary units or using I as part of your solution. So if there are any questions, you know how to contact me. But at this time, we will now conclude this session.